So this theta is the rotation angle, and also the scale can be considered over here. So earlier we say C and D; these are the two parameters, and of course you can view A and B as the other two parameters. Of course you can view it like that. But however, if you want the parameters as physical meaning, then it's better to be considered as R and theta. The theta is the rotation angle, and R is the scale. R is the scale. Okay, so yeah, basically, in this case, if you view it like that, then the four parameters supposedly should be R, theta, C, and D. So the four parameters are including two translations, two shift, you can say, two parameters for shift, and one for rotation, and one for scale. Okay, so that's the conformal transformation function. So the next, actually very famous coordinate transformation function in photogrammetry and remote sensing field is called affine transformation. And this affine transformation also has the other name, which is called the sixth parameter. Six parameter transformation function. In Chinese, 六参数转换 and 四参数转换. Okay, so So basically, these, according to its name, so basically we have 6 parameters. And as you can see, this is the mathematical function for the affine transformation. So the left-hand side is also still the x and y coordinates, small x and small y. And then right-hand side, including large x and large y, which is the other coordinate system. And beside that, we have the a, b, c, d, e, f, 6 parameters over there. Okay, 6 parameters over there. So that's from the mathematical point of view. But how about from the well, we can say like geometric point of view? So still we have the small x and small y over here as the this coordinate system, and we have the large x and large y coordinate system over here. So let's start from the easy one. So as you can see, similar to the conformal transformation function, the 2 origins they are not matched. So we need to have 2 parameters for one for the x-axis shift and one for the y-axis shift. So the c and f they are for this purpose, the c and f over there. And beside that, similarly, as you can see, conformal transformation function, we have the rotation angle, right? And but however, from the conformal transformation function, like I said, the name tells you the story, which is to preserve angle. So which means that from the conformal transformation function, actually, if you have, for example, one direction or one, let's say, one square. For example, if you have a square in the small x and y coordinate system, after you perform any types of conformal transformation, the square is still a square in the large xy coordinate system, because the rotation angle for the x-axis and for the y-axis is the same. So it's rotating with the same rotation angle. But that's not the story for the affine transformation. So as you can see, we have a rotation angle for the large x-axis, and we have the other rotation angle for the large y-axis, which means that if you want to perform the transformation function, the x direction and y direction, they are rotating independently. They are rotating independently with 2 different rotation angles. So as you can see, the theta angle is the x-axis rotation, and the psi angle is the y-axis rotation angle. Well, it is the y-axis rotation angle. So, and that's the other 2 parameters. So c and f, those are the 2 parameters, and theta and psi, they are the other 2 parameters. But we have 2 more. So the other 2 more, which well, should be a very simple question. Yun, what are the other 2? What are the other 2 parameters? C is over here, right? That's the shift for the x-axis, and F is the shift for the y-axis. Alright, Zheng. R and S. What's R? What's S? The scale, right? So it indicates that. So what does it tell us? Why do we? So earlier, for the conformal transformation, we only have 1 scale, and here, why do we have 2 scales? What does it tell us?
Because x and y axis is
What does it tell us? You are correct. They are 2 scales. Do?
Yes. I think you say there are 2 different direction between.
2 direction.
Yes.
So yeah, 2 rotation angles, right?
Yes.
So but how about R and S? The scale.
Yes.
What does it tell us? Earlier, for the conformal transformation, we only have R. And right now we have R and S.
Because we have 2 different angles, so we have 2 different scale.
Well, 2 different angles doesn't indicate you need to have two different scale. You can also have one scale. You can still have one scale, but however, it's not related to whether you have two rotation angle or not. Okay, so, but however, it indicates that. So as you can see, we have the C and F and theta and also psi. And so the other remaining two parameters is R and S. So those indicates the scale. Those indicates the scale for the x-axis and y-axis. Okay, so as you can see, I kind of intentionally to draw a very different scale, like exaggerate it. So this is the original scale. However, the x-axis, when you transform into the new coordinate system, then that's the new scale. And here is and it is different from the scale in the y-axis. So as you can see, it's a very dense over here, and it's very sparse over here. Okay, so that's why I intentionally draw it like that. So which means that the affine transformation allows you to have two different scale. One is along the axis, and the other one is along the y-axis changes. So in this case, the 6 parameters, if you want, of course, you can say A, B, C, D, E, F, and those 6 are the 6 parameters. But if you want to talk about that in terms of their physical meaning, then in this case, you can say C and F, and R, S, theta, and psi. Those are the 6 parameters. Those are the actual 6 parameters. A, B, C, D, A, B, and D, E, they are just like the combination from the R and S and theta and psi. Alright, so let me summarize this part. So basically, the affine transformation it considers 6 parameters, and those 6 parameters are for 2 translation, X translation and Y translation, and which translation means shift, 2 shift. And then you have 2 rotation angle, one along the x-axis, one is for the x-axis, and the other one is for the y-axis. So you have the theta and psi. So it allows 2 axes to rotate independently. So that the angle is not preserved over here, which means that. Okay. So and the other remaining 2 is R and S, which is the x-axis scale and y-axis scale. Okay, so basically for the affine transformation, 2 rotation angles, 2 rotation and 2 scale, and also 2 translation. Those are the 6 parameters for. Okay. Any questions? Okay, if not, then let's move on to the next one. Alright, so the third one for the 2D to 2D coordinate transformation functions, and the third one is what we call the 2D projective transformation function. The 2D projective transformation function, and in Chinese it's called 二维投影. So it's actually 2D is 二维, 2 is 2, 2 is 二的意思. Right, you guys should know it. Right, and D means dimension, right? Dimension is 维度的维, right? 2 二维. Projective is like project. You're projecting something. So in Chinese it's called 投影, right? 投 means shooting, and 影 is like mapping, shooting and mapping. So it's like projection, reprojection, like something like that. Alright, so 2D projective transformation function. This is the mathematical format of that, and as you can see, we still have like small x and y in the left hand side and large x and y in the right hand side. And beside that, it's called 8-parameter transformation function. In Chinese, we will call it 八参数转换，四参、六参、八参这样的意思。Alright, so we have 8 parameters. So as you can see, here we have A1, A2, A3, B1, B2, B3, and C1, C2. Alright, so those are the 8 parameters. So, and what exactly is this 2D projective transformation for? Actually, it's very difficult to draw it. It's very difficult to draw it well, over here. Or you can say my drawing skill is not good enough to draw it. But let me describe it to you guys. So basically, the idea for that is, like I said, it's the 2D to 2D transformation function. So if imagine right now you have one image plane, one plane over here. Right now I have a plane for the coordinates. Y coordinates is an O here, and there's the other plane. For example, the ground is the other plane. The floor is the other plane. So the